This is Mechanical Analytical 3, and we're going to look at the instructions. We are simply going to zoom in on the instructions. It says here that there are two views given. These are the two views that we see there, and then there's a table of questions, and you need to ensure that you answer all those questions pertaining to the two views that we see here of the adapter. So let's start with number 1, and let's go through it and see how we find those answers. The first question is, what is the title of the drawing? And so you go into your title bar there and you see adapter plate, and you're going to write it in here, adapter plate. Your answer there. And then we're going to the next question, which asks for on what date was the drawing checked. So you go to your title bar over here and you see checked by Z Khumalo, and then the 25th 05/09. 25th 05/09. Who approved the drawing? Go down. There it states approved by P.P. Steyn. And you're going to write that in here. So answer P.P. Steyn. What is the number of the drawing? What is the drawing number? So you're going to go here and you will find that the drawing number is Q1/DOE/10. So I repeat, that number is going to be Q1/DOE/10. Okay. If the scale is 1:5, or if a scale of 1:5 is used, what would a dimension of 10 read? Now this is a trick question, and I need to repeat that it's a trick question. Your answer is simply going to be 10. Right? Don't try and multiply this with that over there. The reason is that the scale is changed every time on certain drawings, but the actual sizes of the component remain the same. I repeat, the size on the component remains the same. The scale changes from drawing to drawing. Okay. So whatever they ask you here, you will write in the same number as requested to be changed. How many surfaces on the component require machining? So you're going to go and you know for a fact that that is a machining symbol, but you need to find that symbol on your drawing here. So you need to find how many times does it appear. So I'm going to count, and I want you to count basically with me. So we're going to say 1 and 2, right? That's for this bottom and that top there. And then it's going to be 3, 4 for this bottom and that top. And then 5 and 6, right? That's bottom and top. 7 and 8, and then the last one you are going to find there, which is 9. Now you're going to find significantly that there is the bottom and top of this circle here. This here is the bottom and top there of this semicircle component here, all the circles. That there, bottom and top, is this one, circle there. That bottom and top is this one, the circle there, the holes there. Okay, so that's how you get it, and then you're going to write in the answer 9 there. What process must be applied to achieve the required finish? Right, we're going to go back to the symbol, the machining symbol. And that is basically the process, grinding is the process that's required. So you're going to write in your answer as grinding. All right. Back to the question. As what type of mechanical drawing can the views of the adapter plate be classified? This is probably a component which is very small, which has been blown up now to a specific size, and that's why it can serve as a detailed drawing. So you're going to write in here detailed drawing or a detailed view. You don't want to use detailed drawing or detailed view. Okay. Then what would view 2 be called? So you're going to go, what view is that? This is in third angle, this is my front view, and that is my top view. It is placed on top of my front view. So that is my top view there. So I'm going to write in top view. Number 10. What is the thickness of the rib marked A? So we're going to go to the drawing. There's A. That part there is a rib. That's also a rib. They ask you what thickness. You're not going to find the answer here, but you are going to find the answer here. You know, that refers to that component there, and you can check. That component there, that's the component there. And all these things will line up as you see it there. Alright? Just to show you, that will line up there, that will line up there, these will line up here, they're all lining up. So if you refer to the rib, right, you're going to go to the top here and you're going to find here, that part there, that's the rib, that's where it goes like that there, and it's going to be 11. Right? So you're going to write in your answer are 11. That is your rib. Determine the dimensions at B, C, D, and E. Let's go to B first. And B is going to be right here. So you want to find that dimension. How do you get it? You go back here and you see that that is 42, right? And that 42 goes till there, from the bottom, 42 till there, and you just add that 10 extra there that you see. So 42 plus 10 gives you 52. So that's going to be B, 52. Okay. And if you go to C, C refers to this part over here. You're not going to find the answer here, but if you are going to line that up there, right, line it up there, and you line it up there, you will see it is this component here. So from that center till there is 15 radius. From the center till here is 15. That's 15. Plus another 15 till there. That's 15 and 15. That's 30. And if you go this side 15 and 15, then all together it's going to give you 60. You go to C and you fill in 60. Okay. Now let's go to D. D refers to this part over here. You're not going to get the answer there, but if you line it up, you're going to find that D is basically going to be this circle that we see here. This circle here. And that circle, if you carefully look at the arrows, it's going to be 22 from here to there. So you're going to write in that D is 22. And then E. Right, if you go to your drawing to find E, you scan here is E. E refers to that little small hole over there. Right, that small little hole over there. But you're not going to find the answer. So if you link it down, right to the bottom here, you're going to find that that small hole appears there as well. And that's an M8 that you're going to see in your answer. That's an M8. All right. So question number 12. What is the linear distance between hole 1 and hole 2? So if we're going to move across here to our drawing, there's hole 1 and there's hole 2. Right, so what you need to understand here is you can take a ruler. It's from this center line to that center line over there. So you've got to mark it right in line with that point there. And if you go to this center line here, you can actually find that if you move up, it's with that whole center hole there. So what you can see is that the difference between the two is the distance between the two, and the difference between the two would be that amount there, which is 23 and 41. And 23 plus 41 is going to give you 64. Okay, so we're going to write in the 64 over there. 13. What type of symbol is shown at 3? So we're going to look where number 3 is. Number 3 refers to that particular symbol there. It looks like that, a reference line and an arrow line. Okay, that is a welding symbol. This is more a grade 12 question, but we'll introduce it in grade 11. That's a welding symbol, so I'm going to write there welding. Right, I can write the word welding or welding symbol, but you don't need to write symbol because symbol is already there. Okay, and then number 14, what does the circle on the symbol at 4 mean? Going back to the symbol, there's a circle on the kink part there of your welding symbol. That basically means, also grade 12 question, that you can weld all around, right? Meaning weld all around the component, and I will explain it quickly. So should you have a component, and I want to take this little piece of paper to explain, should you have a cylindrical component that's going to be welded on a base like that, okay, so basically what's going to happen is that you must weld all around here, and that symbol indicates that that is going to be the case, okay, that you do the welding all around the circle, or even if it's a square like that, that the welding must go right around. Okay, that's basically what it means. Continuing with question number 15, what type of section is shown at number 5? So we go to number 5, it refers to that section. According to our notes, it's inside, it is not taken outside of the component, it's inside, so it is going to be a revolved section. Right, so you're going to write here, revolved section. It's a revolved section. If it was outside, that would have been outside here or outside there, aligned to that specific place. It would have been a removed section. Okay, let's go to the next question. Number 16. What is the permissible tolerance on the dimensions of the component? So there are tolerances. Now tolerances refer to offsets, right? Up or down, a fraction of a millimeter up and a fraction of a millimeter down. So where are you going to find that? You're going to scroll down here, and there in that specific title bar and block it says the tolerance on dimensions is plus minus 0, 3. Right? That's very important. Unless otherwise specified. So 0, 3. So that means 0. It is 0, 3 up for the plus and 0, 3 down for the minus. So it can either serve as your maximum or your minimum tolerance. But we'll speak about that more in grade 12. So what we're going to say here, the permissible tolerance according to the block here, it is 0, 3 in the title bar. Determine the tolerance for the dimension at 6. Now number 6 you will find has a specific tolerance there. right? It doesn't refer to this because this is now the otherwise specified, right? Here you have 14.27 on top and 14.47 at the bottom. So all you need to do to find the tolerance is the difference. You're going to say 14,27, which is the bigger one. 14,47 is the bigger one, and 14,27 is the smaller one. And you do a little calculation, just reminded where the commas should be. That's going to be 0 there, right? 7 minus 7, 4 minus 2 is going to be 2, 14 minus that 14 there is going to give you 0. So we don't normally write the 0 here at the back, and we are just going to write our answer as 0,2. Okay, the last two questions, 18, right, we've done already. 18 in this specific block here. In this box here, draw neat and freehand the symbol of the projection system used. Remember what we said, this is a very important question, normally comes in the grade 12 paper, will come in the grade 11 paper as well. You start by looking at the little small chain line there, and you cross it, and you put a long line that side and a long line. So all the lines are now basically centered. Okay. Let's look at the last two questions. Number 18. In the box below, draw a neat freehand the symbol of the projection system used. We've done this before in our previous exercise. It's normally asked in grade 12, but we're going to be asking this in grade 11 as well. So you identify the little small line there, and you're going to cross that line there, and you're going to put a long line there and a long line there, and then small circle, big circle, right? Small line for that circle, longer line for that circle over there. Connect the 2 points, as easy as that, all freehand, and that will give you the 4 marks that it requires you to do. Alright, and then the last one, number 19, in the box below, draw freehand again. Both are freehand. The SABS 0111 convention for the given internal screw thread. Remember, all that changes here is that we don't draw screw thread like that. That's basically a picture, but we draw it as double lines on the side. So you're going to start with this S there, that is sort of break there. This refers here to an internal screw thread, so which basically means that this hatching here, should you be asked what it is basically, or the type of sectioning would probably be part section because of the wavy line. So now we're going to draw a center line through the middle first, and the center line is a long short chain line, and then we're going to draw these bottom parts like that first, connected like that. That's that part over there, and then we're going to put a wider section there and draw it till there like that on both sides. And then of course here you are going to draw the double lines in line with that there, and the double line in line with that there, right? And then you are going to hatch everything there, right? Look at where I hatch. I want to zoom in on that part there. If you hatch, you're going to hatch everything here, not that. So this is going to be hatching inside the screw thread as well, not that. That will not be hatched, that's part of the threaded section, but inside the screw thread the hatching basically continues. And that's your freehand drawing that you have there, and that basically concludes our analytical mechanical drawing. And I hope that you guys have learned a lot from how the questions are structured and to be able to attain some information and knowledge. I hope you enjoy it.